OS models and runtime models, and also allows a mechanism for kind of direct compilation of skeleton application source code. So you can basically take an existing application, semi-automatically strip out some of the actual compute, and then just have the skeleton which only does the computation aspects of that, and directly run that in SST macro in order to look at performance with different network topologies and network constraints. The big focus of SST macro has been on co-design of application and runtime, looking at different middleware and programming language and programming model designs. And currently we're working on efforts to integrate macros, some of their parallel discrete event algorithms into the SST core, as well as integrating macros component models with SST's other models. So just generally about the SST 6.0 release, the virtual machine which we distributed is sort of an early release candidate for that. Probably in the next week or two we'll be having the actual SST 6.0 release. This will be a pretty significant update, probably one of the largest changes to SST yet. As I said, we'll be adding the threaded core. We're using C++ 11 threads, so we can do both MPI and MPI plus threads or serial core. We changed the serialization mechanism to be a more optimized version, which we developed in-house at Sandia. This will further improve a lot of the multi-node MPI performance. At a kind of software engineering level, we separated the core and elements aspects so that they're a little less interwoven, which will make it a little easier to kind of mix and match those, and also easier for people doing development of external component libraries. And as I mentioned, the SST macro element library is going to be added in. Overall, SST 6.0 probably has over 600 changes to the core and elements. Most of these were driven by research experiments and feedback, particularly feedback outside of our group. A lot of posted issues on the SST mailing list, or external customers from academia or industry who we've been working with and have kind of requested new and improved features, have really been the driver for a lot of the improvements which we've seen in SST 6.0. All of our releases and all of our development is performed on GitHub. Our next release will have support for Ubuntu, Red Hat, CentOS, and Mac OS. And we have kind of a lengthy nightly regression suite, which is running to keep us up to date on all of those. So, kind of to wrap up, SST have a lot of information online. We have a wiki which will be updated for the 6.0 release, which will provide information on downloading, installing, and running SST. There are a number of examples in the current distributed release, and we'll be adding more for 6.0. The current download includes both element libraries and the core. There are also guides for extending SST and information and documentation on some of the APIs like SimpleMem and Simple Network, as well as the kind of component to core interface, which kind of is the foundation of SST. We also have some information, as well as our bug tracking information on current development efforts. For additional help, we'll make all of our contact information available. Plus, there are a number of mailing lists. SST user is probably our most frequently trafficked list for questions on building and compiling and extending SST. There's also SST developer for a lot of the more kind of internal aspects of SST, as well as kind of announce. And if you really want to see every time we're committing code, there's SST commits as well for a variety of mundane things of that sort. And all of these, there's subscription information available via the wiki. So in wrap up, hopefully this morning we present the idea that what SST is and some of the components in it. It's a parallel flexible simulation framework. It has a big emphasis on modularity. and the ability to simulate things at multiple levels of granularity. It's capable of simulating modern architectures. We validated against a variety of different components or different architectural artifacts, and it's designed to be very easy to extend and to actually be a useful tool for getting architectural experiments done, rather than just a simulator, which you have to spend lots of time, learning how to simulate. The modularity and this kind of multi-scale aspect fits very well in with its ability to be a parallel simulator. We've baked parallelism in from from our early development, and done it in such a way that it's largely hidden from the component writer, allowing you, the architect, to focus on architecture, not focus on simulation. So, as I said, SST is largely driven by requests and concerns from the community. So if you have any thoughts on features you'd like to see, we're very interested in hearing those and getting that feedback, so we kind of know where our gaps are and what directions we need to push in. I think we have a